everyone! My name is Alex Nusha Jafari and I'm here with Irfan and we're going to teach you systematic design with interface. Once again, this is a video series going through AP Computer Science done right, and it's a book that is available on Amazon and you can purchase it either as an ebook or a paper copy. So today we're just going to go through section 4 of chapter 2. Irfan, are you ready?
Yes, let's go.
Excellent. Before we get started, could we just do a little review of chapter 2.3 and what we learned in the last class? So if our viewers are not familiar with any of the concepts, they can go ahead and rewatch the videos. Irfan, do you want to tell us a little bit?
Sure. In the previous section, we learned how to show complex designs with UML diagrams. We also discussed a little bit about the interface again. Is that right?
That's exactly right. We talked about UML diagrams and we talked a little bit more about interfaces. Are there any questions or anything else that you'd like to talk about regarding UMLs or interfaces?
Actually, I still have a question about the UML.
Absolutely. Go ahead.
So, as you were explaining UML, you said that when someone new wants to get to the team, get to the programming team, let's say,
Yeah.
It's very more clear for them if they have this UML diagram before they get to start.
Yeah,
And I
absolutely.
was wondering, is that so common and often for new persons to join the team? Do
Yeah.
the professional programmers really do this UML diagram thing?
Yeah, that's actually a great question. So, firstly, it's actually very common for new members to join your team and be able to change. Typically, a software engineer usually stays at a company for about 2 to 3 years. So, from that, you can assume that there's quite a bit of a turnover. It obviously depends on the market, but there are new people all the time, and you want to explain to them complex situations all the time. And different companies would draw the UML diagrams differently, but the essence of the UML diagrams are very much used in professional places as well. And not just for the new team members, we talked about the different architecture designs that you would need to have, but you certainly need to have design documents for new team members and for yourself because in a few years you will have forgotten everything that you have done already. Does that answer your question?
Okay, yes, now it makes sense for me.
Excellent. In that case, let's get started with chapter 2.4, which is super exciting. So, this is another design um, concept, I would say. And really, we're trying to focus on what makes a great programmer, someone who is like absolutely fantastic, versus someone who is just good and mediocre. Okay, let's get started. So, remember the last sections we talked about, the exercise domain. And we went through this design exercise where we would have, the type of exercise, the strength, the cardio, and what was useful in each of them. Now, if we just jotted down the important bits, the design recipe, the design of the full architecture of our code base just kind of falls really naturally from this. So, if you remember, we initially, before learning about interfaces, we had different ideas about how to represent this. We first thought we could have just one class. Everyone, would you like to mute because I can hear myself?
Yeah,
Um,
mute.
so if you remember, we just had one class, and in that one class, we had, we could have something like is cardio field or an is strength exercise. Um, and then eventually we had two classes, but each other public classes needed to have two different methods to deal with a strength exercise and a cardio exercise. And then we essentially had the two classes and the one interface. Now, the question you need to ask yourself here is that how is it that we decided from all of these different options that we had, the last one seemed like, the correct answer or the best answer, even though theoretically all of these would work. You could, write tests where you have only implemented one class and all your tests would still pass and you could still have all the functionalities. And you could do so with two classes and no interface. And obviously we did it with an interface as well. So the question really begins to stem from which one is the best one and why is this the best one? Irfan, I'm curious to hear your thoughts. Why do you think we picked this last option as the best option? Or why shouldn't we go back to, let's say, this one because, it works, you could pass?
So, as you said, I think they all work, but the last one with the interface, I think it's very more clear to code and also to understand.
Excellent, excellent point. It's very clear to code and also very clear to understand. I'm so glad you said this, Irfan, because a lot of our job is to code something that's easy to understand. Because more likely, you're going to code something for someone else to see at some point. You're not coding just for yourself if you're working at a big company or at any company, honestly. Because in a few years, you might leave to a different company and someone else needs to understand your code. Excellent. Okay, so really the focus really needs to change and shift to what is clear to understand and clear to code and stems from real information as opposed to code that just works. Those are just like mediocre programmers. We want to be great programmers. So, as an exercise of how to lay out this foundation, let's go through a new idea. Let's say you work at Trader Joe's. I don't know if you're familiar with Trader Joe's, Arfan. Are you familiar with Trader Joe's?
No, unfortunately.
So Trader Joe's is a supermarket, and it's known for something that's not too expensive. It's usually an inexpensive option, and it's nationwide, and it has a bunch of things, anything that you would have. I wonder, do you have like supermarkets that you go to a lot in your town?
Of course, yes. They're called Walmart, maybe.
Oh, Walmart. They're called Walmart in Turkey? Interesting. I didn't know that. We have Walmarts too, but they're definitely not supermarkets. So excellent. All right. So let's say you are working at Trader Joe's and you are now in charge of a new cashier lane, a new cashier um, lane that people can use only for fruits and vegetables. So if you have only purchased fruits or vegetables, you're allowed to use this lane. Otherwise, you have to go through the normal security lane, I guess, or the cashier lane. Does that premise make sense? Do you understand what I'm saying?
Yes, I do.
Excellent. Okay. So in order to program this new cashier lane, we have to know about information about fruits and vegetables. So we want to have, separate information. So fruits typically have a count, right?
Right.
Yeah, so typically like you have two grapes and then you can purchase it by, the count times whatever their fixed price is. Vegetables feels like a different though, right? They're more like weight probably. And they typically just have a complete price. So, for example, a bag of broccoli is going to be $10. So I don't know what Trader Joe's is selling them for $10. That seems really expensive for one bag of broccoli. But it's essentially just a fixed price overall. It's not a multiplication of the count. Does that make sense?
Yes, it makes sense.
Excellent. All right. So let's say we're going to design this. And I'd like to have all the information here. So how would you, if you were to just like doodle things, how would you design this information as data?
I would create two different classes, one for fruits and one for vegetables.
Okay. Before we think about what kind of classes or what kind of interfaces or whatnot, let's just think in terms of pure information. Let's forget about all the coding and programming concepts that we've learned. Let's just focus on what information we have. So we know that we have something to do with food, right? And we know that we care about vegetables. All right. What information do we care about in vegetables?
Right. I think we care about their price, their calories.
Yeah. What else?
And also their weight, as you said.
Mm-hmm. Yeah. We probably also care about their name, right? If we're designing a cashier, it needs to have like a name. Okay, this seems right. All right. We also said we care about fruits. What do we care about fruits?
I think also name again,
Mm-hmm.
price, calories, and let's say counts maybe.
I think, yeah, count could be one for sure. And also price could be one. Or I guess we already have price, so we don't need price per count. So that makes sense. All right. So this is the information that we have. If you look at this, the design of things just kind of naturally fall from this. It's very simple to see. Let's use a different color. All right. So it's very easy to see. We have a food which has categories, vegetables, and fruits. So it's easy to understand, right? It's just going to be probably an interface food with classes, vegetables, and fruit, right?
Right.
Okay. What else can we tell from this information to this design?
We'll probably have to have methods to calculate their cost and calories maybe.
Yes, exactly. So we probably convert these into methods. What else?
What else do we need?
I feel like in order to represent this information as data, what we can see already is the commonalities too, right? So they have a price commonality, they have a name commonality, and they have, a weight and a count. But what really makes the difference for people outside of food and the food class is their name and their price, right? I probably don't care about their weight. All I care about is the final price. Does that make sense?
Exactly.
Okay, great. Yeah. So then we can say, okay, so the interface will have get price and get name. And then each different class will calculate its price method, and dynamic dispatch can do the work for us and get from food to the food price in vegetables or to the food price in the fruits. So far, so good?
Yes, it all makes sense.
Excellent. You can also draw the UML diagram for this. It's very, very easy to do so. So this is a very short and simple class, and it's easy to think, oh, these are very easy and I don't need to worry about them. But this is probably the most important sections. Having good design is what separates great programmers and people who can get, great jobs all the time with people who are less great, I should say. That's what separates between the two. Okay, are you ready for your favorite part?
Let's go. Let's start the homework part.
Oh, I'm so glad you know what your favorite part is. All right. Someone has accidentally pushed the world's reset button. So the world has now reset and everyone's memories are gone. Incredible. All the scientists, engineers, chefs are frantically running around and trying to rebuild and remember everything. The most problem, the most pressing problem, do you know what it is?
Like the most hardest problem?
Yeah, the hardest problem, the biggest problem in the world when this reset button has happened, you're not gonna guess. It's
What
to
is that?
it's making sense of human clothes. Human clothes are so confusing if you don't have a memory of clothing and fashion. What are these limbs? How do these clothes, fit? Like how do we stay warm? So we want to design a program that represent clothing items. So items like skirts, pants, tops, and shirts. We want to accurately code their similarities and differences. We want to essentially build a closet and save the world and be a hero. All right, any question about this?
Let's go. Let's become the hero of the world.
I'm very excited for this. All right, thank you so much, Irfan. Have a great day.
You too. Bye.
Bye.